Hi, this is Roger from Kanka Labs, and perhaps you might have already discovered in our online shop that one of our specialties are tube or valve experimental kits. The reason is that we discovered that many people of my age, plus minus 10 years, they grew up still in the tube area with tube radios, tube TV sets and tube amplifiers. But when I grow to the age where I started my interest in electronics, it was already the transistor area, and all the experimental kits and all the electronic newspapers or magazines, they only dealt with transistor circuits. So only, in my case, decades later, I really wanted to know, well, how do tubes work? And they are fascinating. But I already know, well, you have to deal with hundreds of volts with anode voltages you need, and you need different voltages for the heater in the tubes and for the grids and for the anode. And well, how do you start? You don't know how they work, you don't know where to get them from, you don't know where to get the voltages from. They are also a bit dangerous. And the perfect solution for that is our Tube Experimental Kit RT100. I hope it gets in focus. And with this kit, you can experiment with safe 12-volt DC voltages. You don't need any more, any higher voltages. You get supplied not only the base unit, but also a manual on CD in English and German, and 4 tubes which are specially selected for the experiments, and a lot of passive components. And in this first part of our series about the RT100 kit, I'll show you a bit of the features. What else do you need to work with it? And what can you do with it? And of course, in this series we'll build amplifiers, we'll build radio kits, and we'll build circuits that also generate high frequencies. I think you know what I mean. So let's take a closer look at the RT100 kit and its components. So central are of course the 4 tube sockets, where I'll later show you how to wiggle in and wiggle out the tubes without damaging them. And on the outside we have 2 7-pin so-called B7G or mini or pico sockets, and in the middle there are 2 9-pin sockets of the type Novel or B9A. And these 2 kinds of tube sockets are for the best available tubes today and for the most useful ones that are used in our experiments. And as you might have noticed, all the pins are repeated here on the pin receptacles. The tubes are numbered A, B, C and D, and you can see here for tube socket A there are pin receptacles from A1 to A7, which corresponds of course to pin 1 to pin 7. I'll also later show you in another video how the pin counting is standardized on tube sockets. So what is next? Of course we need some power from somewhere, and most of our experiments can be done with a single power supply, for which we use this standard 2.1 by 5.5 power jack. And we have 2 3.5 millimeter stereo jacks for audio in or audio output, however you want it. And of course also here the pins or the connections are repeated here on the receptacles. In this case here L1 and R1, L2 and R2, and of course ground, which are connected to the stereo inputs and outputs. And we furthermore have screw terminals in parallel to these nice little 2 millimeter mini banana sockets. I'll later show you what kind of cables you can use with them and what they are good for. And on the right side we have another 5 free ports, which are repeated here as F1 to F5, and these ones here, E1 to E7, are repeated here. And you might notice there's also a connection C1 and C2 as well as here, and that's for our variable tuning capacitor, which has 2 sections each with 240 picofarad, so that if you parallel them you get even nearly 500 picofarad capacity. And this is of course for tuning either radio circuits or oscillators or anything where you need a tuning or variable capacitor. Furthermore, we have 2 trim pots of 10 kilo ohm resistance, which are repeated here as pot 1 ABC and pot 2 ABC. And then finally the breadboard area with 12 by 23 contacts. And well, that will be it for the baseboard. Now let's take a look at the parts. By the way, you can buy the baseboard of the RT100 alone without the additional components. That might be of use if you already have enough spare tubes, or you need a second baseboard for permanently building up an experiment like a receiver or an amplifier, because I think it's quite nice and it can even serve as a standalone device with a finished experiment. But most people will probably buy the whole kit, where you still get this bag. And let's take a look what's all inside. First of all, there's a CD with the 2 manuals for the experiments. One is in German, one is in English. And if you are interested, you can download the PDFs before you buy, because they are all open source. Then most important, of course, are the tubes. You get 4 of them. 2 of them are of the kind EF95. I'll explain in another video what the numbering means. Anyway, I will already tell you, this is a so-called pentode. And you get 2 other ones, the ECF80. By the way, we sometimes supply, depending on availability, also the 6J1, which is identical to the EF95. So don't worry if you find 2 6J1 tubes in your bag. Both are selected before we pack them, so you get a guaranteed working tubes. And the other 2 ones, the ECF80, there are 2 systems in 1 tube, which means there is a triode and a pentode in each tubes. I'll show you how they look like. The smaller one here is the EF95 or 6J1, and the bigger one is the ECF80. And well, let's take a look at the other passive components you get. We give you 10 different connectors for the breadboard area. If you need more, we also have a set of, I think, 45 of them in different lengths available. And there's still a secondary bag inside, where you still get some cable for further connections, and a lot of passive components. There are 2 quartzes inside them for oscillator experiments, some electrolytic caps, 2 transistors, and a lot of resistors and capacitors. So put that a little bit in the middle. So that's the content of the kit, of the components. And now we take a look at where we take the power from and what power do we need for our experiments. So what do you need for a power supply? As you know, we have only one power input here standard on the baseboard. That's why all of the experiments in our manual to the RT100 are designed to work with 12 volt only. So this 12 volt only input is used for the anode voltage, which is quite low, of course, and we have selected the tubes that we use in the RT100 especially to work with only 12 volt anode voltage. And well, then what you will know is every tube has a heater to generate the electrons. And the heater, that's the little dim orange-red glow that you see in every tube. The heater voltage depends on the type of tube you have. And you can recognize which heater voltage is necessary by either the first letter or the first number of the tube designation. And the tubes that we use start either with the letter E, and that stands for 6 volts, or with a 6, like the 6J1 tube, and this also means 6 volts. So the trick now is that all the experiments are using two identical tubes in a row, which means we just put the two necessary heater voltage of the two identical tubes in series, so that the same 12 volt input voltage supplies the heater of two tubes, or of course also when all four are used, then the heaters of the different tubes are paralleled and of the same tubes are in series. So we only need 12 volts for the basic power supply. And now what current do the heaters need? Well, the bigger tubes, the ECF80, they need 400 milliamps, and the smaller ones, the EF95 or 6J1, they need about 160 milliamps. So in total it is absolutely sufficient if you have one power supply with 12 volts and at least 600 milliamps current capability. Now, what's the easiest way? Well, if you have a lab supply or any other 12 volt supplies, you only need a standard power plug with 2 leads, and we supply this little cable separately. So you can buy it in our online shop, and that's the cheapest or easiest way. And if you don't have a lab power supply, there are also many other different ways you can get your 12 volts from. One of the best ways is to use lead acid batteries. Here I have two with 12 volt, with 6 volts, which you have to put in series to get 12 volts. Now you can see they have 1.2 amp hours, which would be sufficient for 3 hours, about around 2 to 3 hours operating the tubes in the RT100. Of course, you can also get bigger ones like this one, which has 12 volts directly and which has 4.5 amp hours, which would give you nearly 10 hours of continuous operation of the RT100. And you might know that tubes were originally designed to work from batteries or rechargeable batteries. And if you don't want to buy lead acid batteries, you can either use this battery adapters. We have one with already a soldered to cable and the necessary power plug. This one takes up 10 cells of the AA type, and this one is designed for using with nickel metal hydride rechargeable batteries, because they only have 1.2 volts operating voltages, and 10 times 1.2 or 1.25 volts gives you exactly the 12 to 12.5 volts that we need. And we have this second battery adapter where also with a soldered to power cable, and here 8 batteries of AA size fit inside. And this is if you really want to use batteries and not rechargeable batteries. Usually you will use alkaline batteries. And well, alkaline batteries have 1.5 volts voltage, and 8 by 1.5 volts is again 12 volts. So these are the 3 possibilities to use batteries or rechargeable batteries. You can use lead acid rechargeable batteries. You can use nickel metal hydride rechargeable batteries, or you can use standard alkaline batteries, and all the adapters are, as I already mentioned, are available in our shop. So if you want to use a wall adapter, then we have this handy universal power adapter, which gives you 12 volts and 1 amp, and it has interchangeable power plugs. So you can also get it for, this is the European type plug, but you can also get it with American, UK or Australian plug adapters for the same price. Just specify, if you order one, which one do you want. And it's a quality brand, a Meanwell, so it's quite good. But there's one disadvantage. This of course is a switched mode power supply, and this gives you some radio frequency interference. So for the experiments where we are building a radio, this radio frequency interference from the switch mode power supplies, they get into the very sensitive tubes, and you can get interference and problems with some of the experiments we are doing in the with high frequency reception. So, and finally we have 2 wall adapters with a higher voltage than 12 volt, and that is 48 volts. We have a small one with sorry only a European plug, which gives 120 milliamps, and a bigger one with 375 milliamps, which also has these interchangeable power adapters. The reason that we now have new in our shop these 48 volt wall adapters is that you might try, when you're doing experiments of your own or expanding the experiments that we suggest, that you also use higher anode voltages. Of course, the heater voltage remains at 6 or 12 volts, depending on if you use a tube alone or 2 in a series, 2 filaments connected in series. But you might know that most tubes are designed to work properly or in the ideal region with anode voltages in the range of 250 volts. And the higher your anode voltage becomes, the more, usually the more linear a tube gets and the more amplification it does. We will see later how this all works out. So in case for having a safe DC voltage with higher than 12 volts, that's the reason why we took these two 48-volt wall power adapters into our program. The amps rating doesn't matter because in the anode there are only a few milliamps flowing. It's not like in the heater where hundreds of milliamps are flowing. This small one with 120 milliamps is sufficient to supply 5 or 10 tubes in parallel. The reason that this one has a higher amps rating is only because it's the smallest one we could get with this interchangeable universal or international plug adapters. So that shall be it for a first primer on how to supply the power to your RT100 board. By the way, the board itself is safe up to 60 volts. It's not tested and not guaranteed to work with higher voltages than 60 volts, and you should never try the real high voltages like 250 volts with the baseboard because of two reasons. First of all, it's too dangerous if you're not used to working with, and you see that all the contacts are open, and you can get heavily injured or even killed if you would work with 250 volts. And the safety distances in the leads below on the PCB, they are not laid out for higher voltages than 60 volts. It might work, but you do it absolutely on your own risk. So, and speaking of 60 volts max voltage for the RT100 book, there was once a German book by our master Burkhard Keinker available, which in translation reads 2 projects from 6 to 60 volts. For me, this is the definite reference book on low voltage tube experiments. It's even one of the reasons why I'm working here in the end. And sorrily, it has gone out of print just a few months ago, and Elector Publishing Company doesn't tell us if they want to republish it. Anyway, if you are having a good knowledge of technical English and German and are willing to translate this book, not only will we reward you for your work, but we will try to persuade in the end Elector to republish the book, perhaps then in English. And if they don't want to, we will try to get the rights for the book and try to publish it by ourselves in a translated version. So if you can read technical German, then and you still can get a copy at eBay or book resellers, and however, if new or used, you should definitely get a copy, because it's one of the most interesting tube books published on low voltage usage of vacuum tubes. And we can't guarantee if it will ever be published neither in English or in German. We simply don't know. It depends on Elector Publishing House. Anyway, contact us if you are willing to help us translating it, and we'll see what we can achieve with Elector. So now let me show you what these 2mm mini banana sockets are good for. We supply special cables with these mini 2mm plugs. They are quite handy. We have them and nice, tidy. We have them in all in 4 colors, of course red and black, and then still yellow and blue, and we have them in 2 different lengths. I think the longer one is 50 centimeters and the smaller one 25 centimeters. They are very useful for connecting parts of your circuit to the outside world, especially if you have higher currents flowing. And we also supply adapters from 2mm banana system to 4mm system. And in reverse, you can also get a set of useful combination of cables and adapters, and they are much more expensive than the usual 4mm banana cables, but 4mm would have been much too big for our RT100 board. And they are made in Germany by high quality company Schützinger. Perhaps you might even see that even the pins are with spring contacts, so it's really a joy to work with these connection cables. I'll still show you two nice little features of these cables. First, they are stackable, so you can put as many one on another as you want. And I'll show you one of the adapter types. That's the one from 2 to 4mm system. So you can see you can plug them here into the sockets, and here on top you can put your normal 4mm banana plugs inside, but they don't fit too directly besides each other. So you should use usually the reverse adapters, which are attached here on the end and which go over to the 4mm system. So that shall be it for our 2mm connection sockets. And finally, I'll show you, as promised, how to wiggle in and wiggle out the tubes into their sockets. So I've changed the position of the camera a bit so that you can see it better. Well, first let's take a look at how you wiggle it out. You should touch or grip a tube always this way with 3 fingers. And now you don't pull it vertically up, but you just wiggle it out a bit. And the same is with wiggling in. You place the pins over the holes in the tube socket, and you take it also with your 3 fingers, like with as much surface area you can touch and as equally distributed force, and then you just wiggle it in and no problems at all. Though I'm a newbie to tube and tube experiments compared to our old graybeard tube experts, I never broke a pin, and I never had someone who taught me. I think it's quite easy. If you do it once, don't be afraid. And the tubes, even if one breaks, they are not that expensive, and you can learn this even after the first try. You know how to work with it. So that was it for today again, and in the next part of the series I'll give you a short introduction to tubes. We'll perhaps even take 1 or 2 apart to take a look what inside and what makes them totally different and so fascinating compared to transistors, and well, how they look like and how they are named, and so that you have the basics to start successfully the experiments in the manual. And in the further parts of the series we'll go step by step through the experiments we have in the manual. So until next time, bye from Kanka Labs.